I'm going to set up an experiment to measure the power in three-phase load using the 2 wattmeter method, and I have 2 feedback electronic wattmeters. The loads are heaters. I've got 2 of them here connected to a socket here. A socket here, that's the blue, and that's the yellow using the old colour. There's a red socket here connected to another heater down here. They're approximately 2 kilowatt heaters. So I've got a main switch here and an isolator here for a little panel here that's got the red phase using the old colours, yellow phase, blue phase coming in from the supply and out to the sockets, and we've got the neutral here as well. So it's a star connected system. I'll turn the power on here, but I'm going to keep it off there when I do the wiring up. So what I want to do is wire this red into the ammeter part of the first wattmeter. So that's the lower of the 2 connections here. I've got the supply side and the load side. So I'll come in from the supply and I need to feed back now to the load. So if I just grab a back here and go from there back. So it's going through the ammeter of the wattmeter and then back into the load. I now need a voltage connection to another phase, so I'm going to use the blue phase as my reference on this. So I'll connect from there across. Whoops, that one's not going to do it. Let's try a different one. These will plug in there, but I'll have to put the fully shrouded non-retractable one into there. Okay, now I'm going to do the same thing on the yellow phase as the source on this wattmeter here. So I'm going to take that green out of there and feed it into the ammeter side and then back to the load. And then the voltmeter connection for the ammeter across to the blue. Let's go in there. I think we can go into that one there, so they're both connected together. Right, now I've got the meter set on 10 amps, 500 volts, and I've got the deflection of the meter to multiply by each of those to get the wattmeter reading out of it. I've already set them to 0. There's an adjustment here to set them to 0. So if I turn this on now, we should get a reading. And we can see on this one, that's 0.8, that's 0.6, so 0.7 is there. So as I said, it's about 0.64, maybe 0.65, a little bit hard to read. And this one's just slightly less than that, it's about 0.63 or 0.62. If I multiply, assuming that would be 6.4 by the 10 amp range, by the 500 volt range, we get 3.8 kilowatts. And on this one, 6.3 times 10 times 500, 3.6 kilowatts, totaling 7.4 kilowatts. What I'm going to do now is I'm just going to measure them using meters. So a voltmeter first of all. And because these are not fully shrouded leads, I'm going to switch off to make connections, so I don't have my hands near the equipment when it's on. I'm on the 700 volt maximum AC voltage range of the meter in the voltage sockets. So the first thing I'm going to do is I'm going to measure between the L1 and the L3. Actually no, so I'll do it across the neutral. If I do it across each of them to neutral, I'm going to measure the voltage. So I'm going to have L1 to neutral, L2 to neutral, L3 to neutral, and then I'll measure each of the currents, and we'll multiply them together and see what the total power is that way. So if I just switch on, I'll make a note of that. So L1 to neutral is 239 volts. L2 to neutral, 238 volts. 238.5 really, I'll just do 230, I'll just do an approximate figure. And L3 to neutral, 241 volts. These voltages will be going up and down as we're measuring anyway, they won't stay stable, but they shouldn't change too much. So that's the voltage measurements. Now I want to take a current measurement, and rather than mess around putting the meters in series, I'm just going to use a clamp on ammeter which I've left on by mistake. I'm just going to clip it into each of the leads. So if I put that into the red phase, L1, and let it settle for a moment, the bottom reading is the RMS value, and that's dropping off to 9.05 0.03. Of course, this takes a while to settle. It's going to end up about 9 amps. So 9 amps, and left long enough it may come down even further than that. 8.99. Just have a limited amount of time. So I'm going to take it off that one. That's 8.99 and make a note of it. L2. My other meter is quicker at settling. 8.75. 8.76. It will vary because loads going on and off all the time. 8.76. And on L3, which is that one there, I'm going to say 8.9. I can't wait for it to settle because it will go up and down anyway. 8.9 amps. I'll just switch that off and do a calculation to see does this come to, so these are the individual voltages and currents for each of the loads. If I work out the actual power on each load and add them all together, it should come to our total power for our three-phase system. So 239 times, right, so I'm going to pause that, I'm going to calculate it with me.